Hello, everyone, and welcome to today's webinar. My name is Melissa Retta, and I'm the Senior Marketing Specialist at Tornatech. I would like to introduce to you our presenter, Martin Tomasic, the Director of Sales, and Cole Rigney, the U.S. Sales Manager. Unfortunately, he will not be able to participate today because of a power outage at his home. Hopefully, he'll be able to be online shortly. Our presentation was pre-recorded to help eliminate the chances of technical difficulties, which was a good thing today due to our power outage, which we did not predict at all. However, Marty and hopefully Cole will be able to answer your questions live throughout the presentation. They'll be able to chat with you through the chat tab and answer questions through the Q&A panel. Also, please note there's a tab for handouts where you can download a copy of today's slides. This presentation will be followed by a live Q&A panel. We'll come back online live to answer your questions. So be sure to submit your questions in advance so we can go through them. Now, let's get started and enjoy the presentation.
Good. Well, let's get started. Fire pump controllers, GPx electric, GPD diesel. NFPA 20, everyone's heard of NFPA 20, National Fire Protection Association. Well, we as a manufacturer have guidelines that we must follow when we build a fire pump controller, and NFPA 20 is that guideline. In addition, we need a UL listing and an FM approval before we can ship any fire pump controller out the door in North America. These are basically independent agencies like Underwriters Laboratory that gives guidance to us as a manufacturer for life safety equipment. FM, again, Factory Mutual is one of the oldest insurance companies in the country, and they also require approval by them to be able to ship product out the door. CE marking here is really more of a European standard. I won't get into that. NYC, New York City, has requirements. So we do have to go into New York City, meet the powers that be, and present and do testing based on their requirements before we can actually ship anything into New York City itself. And that goes for any manufacturer. And City of Chicago has requirements. It's not really a listing or an approval, but it's an option add. Option B11 has an internally mounted alarm panel. And you go out to Los Angeles or Denver, they require additional remote alarm contacts. We'll get into that later. Listing approval certifications. Here's another one, seismic compliance. I think we put this on probably about 4 or 5 years ago. What you're going to find is seismic compliance is really driven on the West Coast. Everything from Washington State through Oregon, definitely through California with the San Andreas Fault there. It actually will extend into Nevada and some parts of Texas. But there are also other fault lines throughout the U.S. that people may or may not be aware of. In the Midwest, there's another one that really runs through, I'd say, north to the southeast that is can impact, the seismic grading itself. I mean, it doesn't happen as often as maybe in California, but I do see a lot of requirements because Washington, D.C. and government facilities do require seismic compliance on a lot of their projects, whether they're military or government facilities. So just be aware that this comes as standard. And in most cases, when we start talking about the compliance, some manufacturers offer it, others you have to have it as a cost adder. Let's get right into the electric controllers, GPx. Again, all fire pump controllers, electric controllers here are service entrance rated, or SUSE, suitable for use as service entrance. They do have a surge suppressor on it. That's required by code. And in general, you see we have a disconnecting means. So this disconnecting means primarily is where you come in, and as you can see right here, as I circle, cabling comes into the ISO switch. It will loop down around into a magnetic only breaker itself. These are typically sized, as you can see, the isolating switch is rated not less than 115% of motor load current itself. Again, This is standard equipment for everyone and not specific to Tornatech, but this is how we mount side by side. As you'll note that both breakers have a common faceplate with the operating device coming up the middle. And what that does is allows equal force to be distributed across both toggle switches of the circuit breaker itself. And it makes it much easier because it's uniform. You don't have a side-mounted device where you're actually operating a spring device here across both with a pivot point, because sometimes over time that spring can actually weaken. The breakers themselves are operated by a flange-mounted operator on-off switch, and the circuit breaker on the left side here again is magnetic. That offers locked rotor protection. It is shunt trip operated, and that's obviously how, when we're sensing a locked rotor situation, which is set at 600% of full load amperage, it will trip offline with an 8 to 20 second range. And that's what happens basically. It will energize that shunt trip device and trip the breaker offline. Electrical ratings. Fire pump controllers electric are pretty easy. I mean, all you really have to do, we're looking at voltage and horsepower. So the electrical readings that you'll see on these controllers are required on the front screen or on the front of the enclosure itself. You need to know what the voltage is phase to phase. You need to know what the amperage is phase to phase, and if the motor's running. These are all requirements by code. Pressure ratings, again, we need to know what the continuous system pressure is. We also need to show what the cut-in, cut-out is too. Pressure and event recorder. It's very critical for troubleshooting and determining if there's been any issues in the field as to what might have occurred. Again, by code, we need to have a pressure reading with a date stamp stored in the memory for up to 5 to 10 years. We actually have quite a few event logging. We like to say almost lifetime as far as the number of events, but nothing's ever lifetime. Again, the requirement of storing it in 5 to 10 years for the events to be able to go back and review at whenever necessary. Data viewable from the operator interface display screen really makes life easier. And we'll get into this down the road because we do have a color graphics touchscreen. And so that color graphics makes everyone's life easier, meeting these requirements by code of the voltage, the amperage, the condition of the motor, the pressure reading itself. And again, it's viewable from the front. We also have a downloadable USB port. And what's nice about that is you don't have to open the door. All you have to do is unscrew a little cap and insert to USB, a couple keystrokes, and you can download all the data that's required, you know, to your USB without even opening the door. One minor comment on that is, of course, without opening the door, you don't have to worry about any arc flash potential with live incoming cables. Modbus TCP/IP is standard. It's been there for many, many years. It's a backbone for a lot of industrial facilities as well as institutional facilities. So Modbus TCP/IP, the registers are located on our website if anyone would like to know. Pressure sensing, obviously. How does a fire pump controller operate? Well, quite easy. We have a pressure sensing line that's about roughly a ½ inch, comes into a pressure block, and really the key to this is the pressure transducer. As you can see in this picture right here, we have the pressure transducer here. We have a test solenoid up on the top part here. And without getting into too much detail there, the pressure transducer will actually activate knowing the pressure of the line itself, send a signal to the operator, which is the brain, and determine whether or not we're below cut-in or above cut-out. As far as the run test solenoid, that is something that is used quite often. As we'll point out down the road here, there is a manual run test, and that would be actuating that test solenoid to drain a little bit of water, activate the system, drop the pressure, and do a test as required by NFPA 25, whether it's 10 minutes for electric or 30 minutes for a diesel. What it actually does is save a lot of water, because you don't have to sit there and open a valve and drain substantial amount of water for that pressure to drop down to exercise the controller. And that's primarily the reason why that test solenoid is there, attaching to the manual run test button, is to meet your NFPA 25 requirements. Makes it much easier. And in doing so, what happens is you're recording it as a test rather than opening a valve and recording it as a pump on demand potential fire or a run. The block itself is rated for 0 to 500 PSI. Standard display set for 0 to 300. That's pretty much more than sufficient. If you get into high pressure situations, let us know. We can do factory adjustments with an option for higher. We could actually do it in the field if necessary. And what's nice about this is that it's all externally mounted. We have a high impact polycarbonate cover, as you can see in the picture right here. And pointing this out, since it's mounted on the bottom left side of the controller, externally mounted wetted parts is actually a huge safety feature. So any facility that has OSHA riding over itself as far as safety concerns would see that as a huge safety advantage, because the one thing you don't want to have is mixing potential water or leakage within a controller, the electrical controller itself, because water and electricity do not mix. And water is a conductive fluid. So that's a huge advantage right there. Cool.
All right. I'm going to start with the automatic power transfer switch. So that's what we call a GPU. So GPX is our electric line, and then plus GPU means that it has a transfer switch on it. So let me show you this little section right here. That's going to be the transfer switch. So you've got the normal side on the left side, and then the automatic transfer switch is housed over here on the right side, which is where it is housed in a separate enclosure and attached to the main fire pump controller. It's got a dedicated disconnecting means, so it has its own isolation switch and circuit breaker assembly. Basically, it's somewhat of a mirror of what you see on the normal power side. It's the same isolating switch and circuit breaker assembly, rated for the same types of loads that you get on the normal power side, and it's also a non-thermal type magnetic only circuit breaker, just like it is on the normal power side. So this is going to explain sort of the process for transferring. If your nominal power drops down to 85% of what it should be, it's going to switch over to alternate power, because the control panel is going to say that the power is not healthy, and it's going to turn on your generator. It's going to switch over to the alternate side, and you're going to be running on the diesel generator at that point. Also, it will switch over if you have a phase reversal. On your normal power side, it will transfer over to alternate, and then it doesn't come back. It'll switch back automatically after it's gotten to 90% healthy voltage. But where it says down there below, where it says time delays, it's going to have to see healthy power for 5 minutes. It is field adjustable from 1 to 20 minutes. But the control panel needs to see a healthy voltage on the normal side before it's going to switch back over from the alternate side. And that doesn't happen until it gets to 90%. So 85% it switches over, 90% is when it'll come back. You can switch it, it is field adjustable. But from the factory, we like to have a 5 minute process before it sees healthy voltage. We just need to make sure
I'd like to add one more thing, Cole, too. Sorry about that. On the automatic power transfer switch, when it gets down to 85% of nominal, that process initiates a potential startup on the genset itself. And there is a delay of 1 to 3 seconds that's field adjustable, because the one thing you don't want with a dip like that is to have nuisance starting all the time. So that's required by code, is to have a delay, but you can adjust it between 1 to 3 seconds. And then what happens is, once as he had mentioned, the genset reaches 90% of nominal voltage, it checks to ensure that we're in sync at 60 hertz and that there is no phase reversal, as he mentioned on that side. Otherwise, if any of those three things occur, you know, again, we drop 85%, but we're in sync 60 hertz. We have to get up to 90% of nominal voltage, or again, the phase reversal transfer, I should say, phase reversal alarm goes off, it will not transfer over.
Yeah, exactly. And also, once we do go back to normal power, the generator is going to have its own cool down process. We have a 5-minute timer, so you'll see a 5-minute timer running. The generator will still have voltage. At the end of that 5 minutes, the generator may shut off. Sometimes they have their own internal timer as well. So it could run for another 20, 30 minutes, depending on how that generator is set. There is an audible alarm on the generator side if the isolation switch is open, meaning you haven't turned the power on the transfer switch side. People ask about that frequently, because if you power on the normal power and you haven't powered on the transfer switch side, that bell is going to continue to ring until you turn the power on. So that's the whole reason for that, is that obviously if the isolation switch is open, you don't have your generator. It's basically, it's not going to do you any good. So we have to have an audible alarm for that isolation switch being open, and then also for the generator start connection as well. Okay, the generator, we've got a transfer switch test button. You can see this icon right here. That's if you have a panel that has the automatic transfer switch, you're going to have this button on there. That button is used to test. So when you press it, it's going to send a signal to start the generator. It's going to transfer power once the generator voltage has gotten up to the healthy voltage that it needs to make the transfer. And it's going to run, I believe it's a 5-minute test before it will switch back to normal power. Those are all field adjustable as well. What this button is not to be used for is while you're flowing water. If you're flowing water on normal power and you try and press this button, nothing is going to happen. The way that we would recommend testing under flowing conditions for switching over to alternate power would be to actually kill power. So kill the power on the normal power side, which will simulate a power loss. Send the signal to start the generator. Everything will start back up, and everything will transfer over. And that's how you can run that flow test in that scenario. But this button is not used for that. It's strictly for exercising the generator and the transfer switch. It's also, so the transfer switch needs to have a provision for manual operation, which is also, it has an alarm for that. You have to have, we need it to stay in the automatic mode. So if it's going to be in normal mode, if it's been mechanically pushed over into the normal mode or the alternate mode and out of the automatic mode, that will send a signal. So that's just something that is required. Manual operations, if for some reason your automatic transfer switch is not working automatically, you can physically switch it over to the alternate position or switch it back over to the normal position. So it's just a bypass for that. But otherwise, it will be just left in the automatic position. Okay, that's everything for the alternate power. This is just going to be some enclosure features. We've got the specific coating, the red paint that you see there. It's a powder coating, glossy texture. Standard is a NEMA 2 enclosure. We can go NEMA 3, NEMA 4, NEMA 4X, and other NEMA types as well. But standard from the factory is going to be NEMA 2. In all of our control panels, this is the one with the automatic transfer switch. This is the one without it, obviously. And these are what we call our size 2 panels. Size 2 and up doesn't have, it does not have legs. So this area down here below is where that's what we call the wire bending space. And every one of our panels comes with this bottom entry gland plate, which we'll have a picture of that later on. But we recommend that you come in through that bottom entry gland plate, not the top, And if you can't go through the gland plate, the other recommendation would be to come in through the side down here. If you can come in through the bottom side, either side would be fine. Top entry is going to be your very last option if there's no other way. We prefer that bottom entry gland plate. And we also come standard with these lifting lugs and a wall mounting system too. It's kind of hard to see these little tiny gray things that you can wall mount over, all the panels. And then the big red ones, those are the lifting lugs.
So, Cole did mention on incoming as an alternative, you can't come in the bottom. You can come up the side of the back of the first 12 inches of these enclosures because they're encased. Again, there's a whole different set of guidelines and rules. If you must come in the top, we can talk about that later. But any entry into this enclosure other than coming in the bottom is going to require a watertight hub. That is in our manual. Even though this is NEMA 2, which is kind of like a drip proof, very light dripping from the top, we require any entry again. And this is by electrical or even alarm people to have a watertight hub just to protect the internal components. The bottom channel irons that was mentioned, they're setting there now, but if you wanted to ever gain an extra 3/4 to 1 inch, you can unbolt each side and flip them over and rebolt them in. And what you'll do is you'll lift the enclosure approximately 3/4 to 1 inch off finished floor or a pad, if that's something that you might need. Little things like that, you kind of learn in the field of what you can do. So thank you, Cole.
Yep. Thanks, Marty. So to get into some of the operational features for fire pump controllers, the two most common ways to start is automatic start and manual start. So automatic starts are going to be based on a pressure drop. That's the way the majority of the systems are set up, is with a pressure drop. So using a pressure transducer, whenever there's a drop in the system pressure, the pump will start up and it'll run until it gets to its cutout point. And then somebody will need to come and manually stop it if you don't have an automatic stop enabled. But from the factory, we're going to be, most of the time, it's going to be automatic starting and a manual stop. You can have that with a remote start signal from an automatic device or just from a pressure drop, which is, again, that's the majority of the systems. It's just going to be that pressure transducer that Marty showed the pressure block earlier on. The other options are manual starts, which is going to be this green button here. So they all have a green button. That's the manual start button. This is our run test button. And Marty has already described that one as well. You press that button, activates the solenoid, just drains a tiny, tiny little bit of water, and will run your NFPA 25 weekly or monthly test. You also have a deluge valve start, or a remote start from a manual device, so a manual push button from somewhere. But typically, automatic starts on pressure drops, and then just your standard start push button there. We're all required to have an emergency start handle, and this is in general for all fire pump controller manufacturers. We all have to have an emergency start handle. Ours is one that you have to pull out and kind of pull and latch to keep it in place. One thing to note when you're using the emergency handle, it has this integrated limit switch. What you need to do, just the idea with the emergency handle is to pull it and don't be too ginger with it. Just pull it and lock it in place. So you don't want to feather it. If it's an emergency start, you just need to pull it and lock it. And that is always going to be an across the line start. So even if you have a soft start or a Y delta closed or part winding or whatever your starting method, if you have a reduced voltage start, when you pull the emergency handle, it's going to bypass that. You're pulling in the power straight into the motor contact. So we're skipping all that other stuff and going straight to the power source and into the motor contact to start the pump and the motor. And that's always going to be across the line. So if you have a big 500 horsepower, it's still going to be across the line. It can be a huge spike in amperage. So again, it's an emergency handle. So it is obviously it's the worst case scenario if you can't get your pump started.
One idea here I want to add to this. So emergency start handle, if you're doing commissioning, a lot of times this is overlooked, but sometimes AHJ wants to have at least one or sometimes even 6. So as Cole mentioned, you want to pull and twist clockwise and lock it, even though there's an electrical interlock there, because what you are actually doing, as he mentioned, is you're mechanically closing the contacts of that contactor itself physically. So there is a procedure that we suggest. It's in our manual. It's actually in a couple of the other manuals. Before you do an emergency start handle, we advise you to turn the flange mounted power handle off. Then turn your emergency start handle and lock it, and then re-engage and turn your flange mounted operator back on, power back to the controller itself. And in doing so, it eliminates what Cole had just mentioned. When you're doing a start like this, you're going to end up doing it across the line. It doesn't matter if you have a reduced voltage controller or not, it's across the line. You could have a big motor there. It's going to draw a lot of inrush, at least 6 times full load amperage. And the arcing that could occur by trying to do that without the power off could do some damage to the contactor, could actually carry it through and maybe a surge or spike to the circuit breakers themselves. So the procedure again, turn the power off, pull your emergency start handle into the lock position, turn your power back on. That is the standard procedure, and we're not the only manufacturer that suggests that. Now, under emergency conditions, obviously that would be the perfect way to do it, but we understand if building's burning and something's not functional and this is the only way, something else might happen. But again, when you're just doing your testing, follow that procedure because it's really the safest way. Plus, you don't have to worry about potential irreparable damage to the contactor or the surge or anything to the breaker from an arc that might occur.
Yep, that's a good point. Thank you. Still on the operational features, stopping. Like I mentioned earlier, we come standard from the factory with a manual stop. You have the option to do an automatic stop after the expiration of a timer, which is set at 10 minutes per NFPA 20. But otherwise, your pump is going to run continuously. This goes for the electric or the diesel. If the fire pump comes on, even once the conditions are satisfied, if it's going above the cutout point that's been programmed in, the pump is going to continue to run. It's going to run indefinitely until somebody comes in and manually stops it. And the reason that we ship it that way from the factory is that an automatic start per NFPA 20 again is required to be signed off by an AHJ. So we don't presume that the AHJ in every market will appreciate an automatic stop. So we send it in the field as manual. And if the AHJ wants to sign off on that, then it can easily be field enabled to be automatic stopping after 10 minutes. Some of the other timers that we have is the minimum run, like an off delay or an on delay for a sequential start timer. If you have multiple pumps running in parallel, then you can have one start, say 15 seconds after the other one, and it's only going to start if the conditions aren't satisfied and so on. However many you have, if it's going to be a sequential start like that, you can just delay each start time. And then the periodic test timer, that's going to be based on that push button. The test where for the diesel, you got to run it for 30 minutes every week, and for the electric is every month for 10. That's the periodic test timer. Those are adjustable.
I have one more comment here I want to add into on the stopping. We don't have it listed, but when you're in the field and you're starting a motor and all of a sudden you hear a loud noise or hum, maybe it's a potential locked rotor condition, maybe there's something blocking the impeller, maybe there's something shorting in the motor. It's always a potential chance. And you know what I'm talking about if this has happened to you. But when that motor starts humming or rattling or growling and it's loud, especially larger horsepower motors, you want to turn that thing off as soon as possible. You're not waiting for a locked rotor to count 1,000, 1,000, 2,000, 3, all the way to 8 to 20 seconds, or immediately, I need to cut the power. Stopping it with the manually with the stop push button is great, but you would have one other option, and that's the flange mounted operator itself. You can literally pull that down and cut power to the whole device itself. So that is another stopping device that we really didn't touch base on, but to me, that's the one I use when I'm out in the field if something like that does occur.
Yeah, that's true. If you have something like that happening, you can always kill the power. That definitely is a stopping, a method of stopping. Okay, some of the visual indications. This screen that you see on the right side, that's going to be the home. Yeah, that's the home screen for our ViZiTouch. That's the brain. We'll get into a little bit more detail on that in just a little bit. But there's certain things that we have to show on the screen at all times, and that's going to be whether the panel is pressure actuated or non-pressure. And we have that displayed here in the bottom left. So like I said, most systems are going to be pressure actuated with a pressure transducer. If it's non-pressure, like a foam system or something like that, it would say non-pressure there instead of pressure actuated. We also have to show if it's an automatic or a non-automatic controller. For some reason, this controller is actually set up to be non-automatic. So even if it is pressure actuated, it's not coming on automatically. That's just the way this demo or this screen is set. Typically, it says automatic controller, meaning it's going to come on automatically with a pressure drop. And then the other thing is the shutdown. So this one is actually, it has the automatic shutdown enabled. But like I mentioned before, from the factory, it's going to have a manual shutdown. But those are three things that we have to have displayed at all times. There's a whole lot of other stuff, and we're going to get into that later.
Sure.
Then we have the standard remote alarm contacts. So there's three that are required. There's the ones that you see in red there. That's power available, phase reversal, and motor on. Those are the three that are required. We also give 3 additional contacts that can be programmed in the field. So if you have, it says it's set for a common pump room alarm, which covers a group of alarms, common motor trouble, which covers a group of alarms. And then we have one that doesn't have anything set already. It's free. You can do whatever you want to with it. You can adjust these other 2 as well, the common pump room and common motor. Just because these 3 that are in red are the 3 that are required. You can't do anything with those. Those are hard set into the programming. But each one of these are double pull, double throw, meaning that you can send the signals to multiple remote alarm annunciators if that is a requirement.
So these remote contacts I'll add in here, Cole.
Yeah, go ahead.
Our double pull, double throw, like you said, 2 open, 2 closed. They're 8 amp rated, 250 volt. They're heavy duty. This is throughout our controls for diesel also. So you have the ability in some cities that require not only just the remote alarm for a local, the alarm panel itself in the lobby of a building, but a distant remote panel. So having 2 open, 2 closed, S standard really fulfills that requirement. Common pump room alarm, it's a catch-all, over voltage, under voltage, phase imbalance, low and high pump room ambient temperature or pump room temperature. Are we down to 40 degrees C or 40 degrees Fahrenheit? Are we above, a certain temperature? So it will alarm that common pump room alarm. Common motor trouble, obviously overcurrent, fail to start, undercurrent, and a rare situation with ground fault. Those last 3, as Cole had mentioned, are not really required, but they're there. They're a catch-all, but you can actually reprogram those in the field to make a single dedicated alarm out of one of those if you wanted to. If you wanted just to have, high pump room temp for pump room alarm, you could change that. The one thing that won't change is the drawings once it's shipped. So you need to make sure you make notes on that. Otherwise, you can pre-order from the factory with an option to have a dedicated remote alarm contact solely for high pump room temperature. But there's a lot of flexibility there. The pull-apart terminals really make life easier for everyone who's connecting to it. So, I've got pretty good sized hands. I reach in to try to terminate a couple of wires. It's much easier just to pull it apart, terminate your wires, and plug it back in. So it's been streamlined.
And if you have a transfer switch, there's also another, I guess you'd call it a bank of alarm contacts, remote alarm contacts. Isolation switch in the off position, transfer switch in normal position, transfer switch in alternate emergency position. As mentioned before, the ideal position for the transfer switch is going to be in the automatic position. If it's not in the automatic position, it's not functioning automatically. Somebody would have to go in there and manually switch it over to alternate and manually put it back over to normal. So if it's in anything other than automatic, you're going to get an alarm. Same with the isolation switch. Like I said before, if the isolation switch is in the off position, your transfer switch is not functional, so you get an alarm for that one as well. And these are set up the same way as the normal contacts on the normal power side. All right, Marty, I'm going to give it back to you on the starting methods.
Let's cover some of the methods. I won't go through all of them, excuse me, because a lot of them have really more antiquated designs. I think the most widely used is right here across the line. Self-explanatory, whether you have 208 volt, 460, 480, that motor, the 3 motor leads you're seeing are going to get full voltage across each of the 3 phases of that motor, excuse me. And typically your full load amperage, the inrush that you'll see is 6 times full load amperage for that particular motor. Again, that's an across the line itself. It's probably one of the most widely used in the industry. Part winding, you know, the only time we get into part winding is really replacements. I don't go out and promote them for new installs. It really, we'll touch base on that in a little bit. Auto transformer. Auto transformer has been around. It's been steady Eddie for decades and decades and decades, well before my time. And really it's a hunk of iron. It's a transformer that typically pulls off taps at 65% voltage. It's reduced voltage, probably 3.5, 4 times full load amperage you'll see on the inrush. It does a great job. It really is something that doesn't break down. It emits heat in the wintertime, keeps your controller warm, obviously. But that technology has predominantly been used quite a bit through the US, but really in Canada. But that business is really, the last 5 years are trending towards soft starts. So there's nothing against this, but there's a lot of reasons why you don't want it to. But that's been an icon in the industry for a long time. And look at it, it's a 3-wired device too. So it takes a standard motor. Soft start. That is been around for a long time. I mean, a long time. Soft starts, electronic equipment tended to be very, very sensitive to temperature and vibration. But through decades of improvement, whether it be any type of electronic equipment, but primarily into starting motors, it's improved. So it's become very efficient. There's some flexibility there. Worst case, if you ever need to tweak it, you do have a few adjustments, and that's a rare case that you might have to, but sometimes it can correct minor inefficiencies in a design of a system. And again, it takes 3 wires. This is quite nice. Primary resistor, again, if we're replacing it, I think I would suggest looking at another replacement for it. You know, maybe a GPS probably would be good. But if we had to build it, we probably could. But the point is, it's really older technology that's been around for a long time and it's been displaced. The last 2, Y delta closed. We get a lot of demand for that still. And Y delta open. I'll show you briefly what those mean on future slides here. But again, you notice there's six wires. And on new applications, again, I always say, hey, 3-wire application, use an across the line, use a soft start reduced voltage rather than a Y delta open or close, because it takes 6 wires. It's twice as much labor, twice as much material to connect it. And again, you're looking at a trade-off now between a Y delta open or close controller compared to a soft start, or even, again, for reduced voltage, I would really push a soft start because it has a lot more flexibility and there's less potential, how do I want to put it, moving parts that could wear out down the road. The big thing here, as you'll note, 3-wire, 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 6 and 6. Typically, again, when you get into this type of a design, reduced voltage is always trying to reduce the current inrush in an electrical system. High inrushes in an electrical system cause adverse effects to the electrical system. It could actually induce noise and spikes back through the system, which could affect other electronic equipment within. Talk about critical production areas, hospitals, radio stations. I mean, different things where you could have that noise impact on the electrical system itself. So here we are, cross the line. Full voltage. It's quite easy. Contactor opens and closes. Here's your 3 lines coming in. And again, T1, 2, and 3 to your motor leads right here. It's very simple. Very simple design. Internal components, pretty easy. Come in the top, loop up into the isolation switch here. It loops around through the magnetic breaker only, down through the current transformers, which are sensing the amperage draw of the motor, to the contactor right here. And this contactor is the workhorse. So I mentioned before, it's quite easy to size an electric fire pump controller. All we need as a manufacturer is the horsepower and the voltage. And all the work and calculations of all the components within this enclosure are done by us. I need the HP and I need the full load, or the HP and the voltage. Now on higher horsepowers, we might get into the fringe area where we might say, hey, we need to see the motor data sheet because we want to see what the amperage draw is. Again, this is typically, you're talking direct online, 6 times full load amperage. You're talking, medium to small to medium horsepower motors, 40 volt, it'd be typical. People ask, where's the tipping point? Well, you might be looking at a 75 horsepower, 40 volt motor. For all I know, typically you could use it across the line with no problem, but it's the application you need to look at. What will be affected in the facility that this is going to start into? When you get into, 100 horsepower, 125 at 40 volt or bigger, it seems that it's a no-brainer that you are going to use a reduced voltage controller. And if it's a 208 volt, you're literally doubling the full load amperage, and in most cases, the current carrying components will double in size too. Definitely want to start looking at using a reduced voltage on a lower horsepower motor if you're actually attached to 208 volt. Here's the curve. All right, look at the inrush here. We got an inrush right here, roughly 6 times full load amperage. You do have a incremental peak inrush. It's almost negligible. It happens so fast. Excuse me. But as your RPM increases here toward full RPM, whether it's 1750 or 3700 or whatever it might be, as you increase your speed, you notice the amperage, it goes down. And so here's the optimum spot right here. We're at full speed and full load running amperage. That's the optimum level of the motor. Reduced voltage part winding, I'm not going to get into. Auto transformer, very brief. Again, we have a couple sets of contactors. We have taps off this transformer right here, typically 65%. There could be other adjustments, factory set, but 65 is industry standard. And again, we're starting off at a reduced voltage, which is going to reduce current. And then as we ramp up, what will happen is, as you'll see briefly here, we have an inrush close to peaking 3 to 4 times full load amperage. Again, this high inrush here is almost negligible, the peak inrush. But as you see, as speed increases here, the RPM, amperage drops down. We do have a slight peak right here because what happens is the speed goes up. We're transitioning from 65% to full voltage, and so we'll pick a little spike up there that's very minimal, but it really is a nice transition. So auto transformer has been used for a lot of years. Again, it's been a steady eddy in the industry for a while. but is being displaced by soft starts. Oh, soft start, here we are. This is that little black box I'm talking about. Again, don't get confused thinking a soft start is like a VFD, a variable frequency drive, because it is alike because they're both electronic, but there is differences. So a soft start will allow you to ramp up the amount, your motor up to a certain speed. Now, we all know on normal power by code, you need to have your motor up and running in 10 seconds or less. That's the maximum amount by code. So a soft start will allow you to do two things. You could ramp that speed up a little quicker if you want, or you could, it's field adjustable, but it's factory set for the optimum ramp up time for that particular horsepower size motor. You could ramp down and have a slow ramp down in cases of that too. I mean, you can go both ways. Really, you don't have to adjust that in the field, but once a soft start ramps up, it gets up to 100% motor speed. Now you're at optimum full load amperage, running amperage itself. Where a variable frequency drive, it's sensing the system pressure and trying to maintain kind of like a flat curve. You want to maintain that pressure, and at the same time, it will vary the frequency of the motor. So the motor speeds up, slows down over a period of time. There's nothing constant about it. It's sensitive to the system pressure itself. So rather than ramp up and go to full speed like a soft start, a variable frequency drive may ramp up for just a brief second to full speed, but ramp back down, trying to maintain the system pressure that was set in it. So your motor might run quite slow over a period of time. Again, soft start economically, it's been the go-to for a lot of years. There's a lot of cities anywhere in the country that have standardized on this. The engineering community has grasped it because it runs efficient, runs cooler. There's really no moving parts. Cost has gone down considerably. So before you look at a replacement, again, look at what the cost of using a soft start as a replacement might be. And if it's a 12 lead motor, it's quite easy to tie in your leads and feed 3 into the control or the controller itself. You can tell I like soft starts, obviously. It's quite easy. Again, you come in the bottom, loop into the top here, same thing. We have a soft start. We're going through the soft start, we ramp up, and here's our contactor for full running speed. Ramp up is nice. Obviously, you see the inrush here, it's set, it shows 2. So let's be realistic, probably 2, 2.5, 3, maybe slightly higher. It is adjustable, but again, if you reduce that curve too much, you need to have enough enough inertia for that motor to turn and break free and turn. So anytime you reduce or make adjustments, you have that risk. They're factory set based on the horsepower, optimum running. Again, if you needed to tweak it, you probably could, obviously, special situations. But as you see, the inrush is a lot less. And as you gain speed here across the horizontal plane, current levels off, and there is no spike. It's just a nice soft curve dropping down to your optimum full load amperage, running at the RPM that it's set for. I'll move a little quicker here. Why delta closed? Here's your resistors. Very simple. What we do is we have reduced voltage, and it's running through a set of resistors, which reduces the voltage, as you see, into the motor itself. And then we transition. Primarily what happens with the resistors, again, they stay in the circuit. And it's called a closed transition. So the motor leads never, ever, ever have an open circuit, an open voltage, or I should say no voltage. What's happening is those resistors stay there, so there's a constant voltage that's applied to the leads of the motor itself, closed transition, obviously. And the reason why, I'll show you the next slide that'll explain that. By having a closed transition, you see we could look at 2, 2.5, maybe a little 3. We have, again, peak inrush, which is negligible, but this is very, very nice inrush on startup. And as you increase to about 85 to 90% speed, you see there's a little blip here. That's going from reduced voltage to full voltage. And by having those resistors in line, we continually have voltage across the motor leads 100% of the time. That's crucial. That's the closed transition. And I'll show you the reason why on open. I'm going to back up here just to show you a picture. Here's your resistors right here. Again, why do I say soft start? These are resistors. They can heat up. They can cool down over a period of time. They can wear out. The material itself that's used for the resistors can lose tensile strength. It could fail. There's a lot of different reasons why. Things could fall on top of them. Soft start doesn't have that situation. It's non-moving parts. It's not something you need to worry about as much. Okay, why delta open? See, the resistors are gone. That's key. What does that mean to me? Obviously, resistors gone here. But here we go. The inrush is very comfortable. It could be 2, 2.5 times. As your speed increases to about 85 to 90% RPM, you notice what happens. Your current drops, and we go from reduced voltage to full voltage. Well, without having those resistors there, we remove the voltage from the leads of the motor, so it sees an open circuit. And all of a sudden, we put full voltage across those leads, and look what happens. It spikes 5+ times, almost as high as an across-the-line controller, because we remove voltage from it, we put full voltage back on the leads. It's almost like a fresh start, even though there's some momentum there with it turning, but the increase is dramatic. So, I mean, I don't really care for wide delta open, obviously, because that affects the system.
All right, I'll jump in with the external components on the control panels. I think we've mentioned the bell a few times. That's I don't know if it's 85 or 95 decibels. It's pretty loud. You can hear it very clearly, especially when you're standing right next to it. Our externally mounted wetted parts here, where that's the pressure block, the pressure transducer. The ViZiTouch here, that's our brain of the panel, the computer basically. Our flange mounted operator. The emergency handle is down here. We mentioned that one earlier as well. And then, of course, the picture that we saw earlier was the size 2 controller or larger. But this one is this is our size 1 controller. So this one does have the legs, as you can see there at the bottom. It's just for the smaller horsepowers. It also can be wall mounted or mounted on the ground on these legs. But that gives you plenty of room in there to come in from the bottom to run your motor leads and your the power cables as well. And also, I didn't mention, we have a 3-point locking mechanism. These silver ones that you can sort of see on here, those are just going to be like you could use a quarter or a flathead screwdriver or something like that to lock those. It's just a little turn that will keep the door closed there. But then we also have this one in the middle. That's a similar design, except that it's keyed, so you can lock that one. And all of our control panels, they come unlocked with the keys on the inside, so we will not ship it to you locked without the key. Just an FYI on that. But that one does give you the option to lock the panels so that nobody unauthorized can get inside it.
I'd like to add a couple things. The keys, as Cole said, they're actually, if you open the door, they're on the bottom left side. They're tie wrapped to the inside of the enclosure. So someone calls, say, hey, I need keys. They didn't come. It's very highly unlikely. Number 2 is these legs, size 1. These are 12 inches. Because code requires from finished floor to the first entry to a power device, it's 12 inches from finished floor to your first termination of power. And you don't necessarily need those legs because you can wall mount this, obviously, makes it quite nice. But I just wanted to point that out because it does make a big difference. I think that right now we ship them without the legs, and there's an option to add them if you need it. Is that correct? Do you remember, Cole?
You know, honestly, I don't know. I thought that it came shipped with them already mounted, but that could be wrong.
But maybe I'm wrong. They take the option to remove them and save a few dollars. So
I believe that's what it is. I think there's an option to remove the legs if you don't need them for packages or whatever. If you're going to be mounting them in a different way, you don't need them to be mounted on the ground. You can have the legs removed. Another thing, I don't know if there's another slide that shows a close-up of this, but over here, I know Marty had mentioned the way that you can get the logs, the saved logs and everything that's inside the ViZiTouch. We have an exterior USB port, so you don't have to open up the control panel to get any of the data off of it. You can just plug your USB port to the bottom right of the ViZiTouch and go through the download process and get all the data that the controller has been taking notes on for ever since it's been powered up. So it'll be your power, your amperage, your pressure, your every start and stop. We keep track of everything, so you can get that data off of that USB port.
Yeah, and you know what, the USBs, you can use any USB size you want. There's no limitations. What's out there in the market, you know, doesn't matter if it's 2 gig, 4 gig, 256 gig. Any of those will work. And as far as the data, I mean, you actually get into more. I think we have some slides that we'll cover on that, but it all loads into kind of like a text file for your data. And then if you're talking pump curves, power curves, pressure curves, it goes into a spreadsheet. But it's not curves; it's actually documented by values in a spreadsheet that you'll see.
The internal components. This is the top left picture here, interior USB port. We also have one on the inside, but we use that in the factory. I'm not sure if anybody really uses that in the field. It can be used, but we have the one on the front side, which is really the one that you should be going to anyway. But this is the back side of the ViZiTouch. The I/O board with removable alarm contact terminals. That's going to be over here. It's on the top left side of the panel. Like Marty said, they're removable so that you can pull those out, wire your alarms, and then stick them back in. Makes the alarm guy's life a little bit easier. Also, alarm folks, if you're listening to this, if you happen to be coming through the top of the panels, like we mentioned earlier, you also need to cover for drill shavings and that kind of stuff. So we have seen alarms wired up where they've come in through the top and got drill shavings and everything inside the component. So drill shavings are something that we try to avoid as much as possible inside of a control panel. Then you have the surge arrestor, the circuit breaker and isolation switch assembly. I think we've seen lots of pictures of that at this point. Your motor contactor, and then the emergency handle, as well as our gland plate. You can see the picture of the gland plate down there that we've mentioned as well. Again, the preferred method for entering the control panel would be to remove the gland plate, drill your holes that are required somewhere away from the panel. You can stick it back and then run your wires up through that gland plate. That just really minimizes the amount of debris that you can get inside the control panel. External components again. This time, this is the controller with the isolation switch. So everything is basically the same bell, same externally mounted wedded parts, same ViZiTouch. And actually, if you notice on the transfer switch side, we don't have a screen. There's no data or anything on that side. That's just the separate barriered housing for the transfer switch that's required. But all of the information is going to be tracked right here in the ViZiTouch. So you don't have two screens to look at. When we have transfer switch, the ViZiTouch is monitoring the transfer switch as well. So two screens are not required on our panels. The internals of the transfer switch, it is the same circuit breaker and isolation switch. We have the same removable alarm contacts. We have another surge arrestor. And also, another gland plate because you also have to run the wires into that. And again, we prefer you to go through our gland plate.
Watertight hubs, remember?
Yeah, watertight hubs. Yes. That's just to maintain the NEMA 2 enclosure as well. Like Marty mentioned, the NEMA 2 enclosure is drip proof. If you start cutting holes in it and you don't put a watertight hub on there, it's actually no longer going to be even NEMA 2. So especially if you've drilled through the top or the sides, if you don't use watertight, the NEMA 2 rating is not valid at that point either.
I mean, watertight hubs really do help any potential condensation within the conduit itself from entering through the conduits into the enclosure. And as we mentioned before, water and moisture does not mix with electricity. It doesn't take much.
No. A single drill shaving or just a little bit of moisture can cause all kinds of issues inside the electrical components. So as much as we can be avoided is preferred.
Sorry, Cole. If you have a situation where you have a top entry required, contact either of us or our great factory sales tech support and Sebastian's group. We have guidelines for those unique situations, and they're pretty thorough. And final inspection will determine which way you go. But there are some really strict guidelines that we follow to protect the internal components, not just the components, but even the wiring and the trough that they're in, because shavings go everywhere and debris.
Yep. All right, now we're going to get into sort of our differentiator from our competition. Everything that we're going to show is things that everybody is required to have. We just do our the way that we show the voltage, the amperage, everything that's happening inside the control panel is unique to our ViZiTouch. Because it is the brain. It is a 7-inch color display and it's actually a touch screen. And it comes with a cover. There's a plastic cover on there. So it happens all the time where people don't realize there's that cover on there. So if you try and tap it and nothing is working, chances are the cover is still on. So you just push the little button and open up the cover, and then you'll see that it is indeed a touch screen. But it's got this USB point right here. I did show you that picture earlier. The ViZiTouch is actually rated for NEMA 4, including this USB on here as well. The whole controller again is NEMA 2, but the ViZiTouch as a standard is rated NEMA 4. And it's actually got multi languages. We have Modbus. Marty mentioned that earlier. Modbus TCP IP is standard on the ViZiTouch.
Yeah, don't be surprised if you have other ways of connecting. I mean, BACnet. Just contact us because we've got the capability of going and interconnecting, communicating on pretty much any system that's out there, any business, I should say, a monitoring system itself. And the one thing also in the fascia of that ViZiTouch itself, embedded in that thermoplastic. I mean, we have a polycarbonate cover that might have some tendencies for UV protection, but I can't really say how much that is. I have to check with engineering. But we have pump room temperatures is standard with our unit. So that temperature sensor is embedded right there in the face as he's got circled. And that's huge in a lot of times, especially for diesels we'll cover, but electric sometimes too. Whoever thinks that the pump room is going to have drop below freezing, and then all of a sudden you have a bad pressure transducer, and it comes to find out that, oh my goodness, you know what? It shows low ambient temperature. It was actually below freezing. No one would know that for a day or two, but it could help. Again, this is where the data logging and all this, especially with pump room temperature, will help you determine what the problem was.
Yeah. This is the home screen of the ViZiTouch. So this is going to be the standard screen that you're going to see once the panel has been put into service. This will be the main screen, and it's going to be showing everything that's happening on the control panel. So I'll just start with going through this screen here on the top left. You'll see this guy right here. Well, I don't know why my drawing's not functioning. But on the top left, you'll see this. There's this three line icon. That's like you'll see that on a lot of websites, especially mobile sites. It's just a drop-down menu. So that's our drop-down menu on the top left. Then you'll see L1, L2, L3 right below that. That's going to be line 1. This is our normal power, and we're showing 480 volts. So that is taking 3 different readings. So you're going to get a reading from line 1 to line 3, and that's 480. Then you'll see line 1 to line 2, and line 2 to line 3. So we're monitoring all 3 phases of power coming in at all times. And one note here on the ViZiTouch, green is good, yellow is like a cautionary, and red is bad. So we've tried to kind of color coordinate things based on green being good, red being bad, that kind of stuff. But you can follow the green line here saying that power is healthy. You'll see these 3 circles here. That's our ammeter. They say 0A in them. So 0 amps, the motor is not running right now. And you can actually see that the motor contacts right next to those 3 sets of parallel lines. That represents our motor contacts. So they're open right now because the motor is not on. And you can also see that circled M there. That represents our motor. It's gray, and it's gray because it is not on. So there's a lot of indications here showing you that your pump is not running. Going back up to the top, you can see where it says home. Right there, we always display what screen you're on. So when you're on the home screen, it says home. If you're on the configuration page, it says configuration. So whatever screen you're at, it'll give you the name. Further over on the right, we have a date and time stamp. And then, as Marty mentioned, we have pump room temperature. So this one is set up for Celsius. You can change that to Fahrenheit, but Celsius was what it comes from the factory. But you can easily switch that. You just touch on it and switch it over to Fahrenheit. But 23 degrees Celsius. And then you'll see that white mark. It's kind of hard to tell what that is, but that's actually our battery icon. So the ViZiTouch has a battery that is being charged constantly, but that shows you the battery health on the top right there, which the battery is something that will last for the lifetime of the ViZiTouch as well, as long as power is running to it constantly.
So looking at the screen, very simple, as Cole pointed everything out, you can walk up and look at the screen and get a picture of everything that's required by code with one single shot, with or without transfer. Green is on or go, red is off, yellow's caution or transition. You see your cut in, cut out on the bottom right. You see your system pressure, 167. Across the bottom tells you what type of controller you have. And top right, as he mentioned, the temperature. So for the most part, most of the customers that you're dealing with probably aren't very tech savvy. And this makes their lives really simple. It's very easy to go in and realize red is stop, green is go or energized, and yellow is caution. And just pointing a few things out, 5 minutes and anyone can understand what the screen means. And that's what the technology has done. The techie people, that whether they're facilities engineering or could be anything, could be heavy industry, or I should say institutional, whatever, governmental, they eat this stuff up and enjoy it. They just love to dig into this. But for the 85 or 90% of the normal people that buy this, who are afraid of electrical equipment or electronic equipment, it's pretty easy to understand.
Yep. Also down here on the bottom right, you'll see it says 167 PSI. That's your system pressure. You can actually tap on that, which I can't do, but the real panels, you can tap on that and actually it'll pop it up even bigger on the screen. So if you're doing a pump test or something and you need to see what kind of pressure, you can actually tap on that. It makes it a lot bigger and you can see it from across the room. You can see that it's got 140 as the cut in. So we have on this gauge here, which says 0 to 300. You'll see the red line. It goes from 0 to 140. So 140 is the cut in pressure. Your system pressure right now is at 167, but if it happened to drop down below 140, it's going to come on. This pump, you can see here on the bottom, it's an automatic controller. It's pressure actuated and it has the automatic shutdown enabled, but an automatic controller pressure actuated. So if the pressure drops below 140 PSI, which is the cut in point, the pump's going to start running. And it's going to run until it satisfies the pressure, which I believe this one is probably set at 160. The needle is kind of blocking that, but you can see the green transition there. Well, from 140 to 160, it's going to be there's going to be a little bit of a yellow line there, just kind of that's in between your cut in and cut out, and then it's green from your cut out point until the end of the meter there at 300. So this one being automatic shutdown enabled, if once the system pressure gets back up above, you're going to have you'll see a timer start going for 10 minutes or whatever you have that automatic shutdown set for, and after 10 minutes the timer has expired, then the pump will shut off automatically. This is the home screen with the automatic transfer switch. So you can see it's basically the same thing. We have a lot of similar stuff going on here, except now we have A1, A2, and A3, and where it said L1, L2, L3, it now says N1. So it's just distinguishing between normal power and alternate power. So we're on normal power right now, and this is where the green is easy to follow. You can just see that we're still on normal power. The normal power is healthy. It's still at 480 volts. The contacts there that you can see are filled in. They're closed, meaning that we're on normal power, and you can just kind of follow the flow of electricity all the way over to the motor. We're actually getting 2 readings on voltage for the automatic transfer switch. So we're taking the first one that's going to be up there at the isolation switch, the incoming power, and then we're going to take another reading right before we get to the motor contactors, just to verify that power is flowing healthily through the whole control panel. So we get 2 readings. Also, it's necessary to get a second reading when the alternate power is on. Since we have 2 power sources, we need to take 2 readings on the voltages. Alternate power right now is red. You can see that it says 0 volts. It's just not on. The generator's not running. If the generator was running and it was set up correctly, oh, my drawing's back, and it's set up correctly, then you would have 480 volts here. They would be green. And this icon right here, actually, the way that you can really kind of tell with our screen which power it's being run on, whether it's normal power or alternate power, is going to be this right here, and also these contactors, plus the flow of electricity. So there's actually a lot of ways that you can see where it's running. But when the transfer switch is on, you'll have voltage here from the generator. You'll have that triangle will actually be upside down, and these contacts that are closed right now, these contacts that are closed will be opened, and these guys will be closed. So you'll be able to flow, and then these lines will be green, and it just shows the flow of electricity coming from the generator side. And also, again, this is all set up. You can see here, this one's automatic, pressure actuated, and this one has the manual shutdown. So we're on the one without it, it was set up to say automatic shutdown. You can see where what it would say if it was a manual shutdown. That's how it's shipped from the factory, is manual. All right, and I'm going to go back to the screen now that I have my drawer is working. I was trying to show you earlier this this icon right here on the top left. That's the drop-down menu. So when you touch on that, this is the screen that pops up. So these are all the sub-menus inside the ViZiTouch, and it goes a lot deeper than this, but this is just the drop-down menu. So anywhere you are inside the panel, if you hit that drop-down button, it's always there. And you hit home, you'll always go back to this screen right here. The second one down below is the alarms. So that's going to be any active alarms. If your pump's on demand, if you have unhealthy voltage, whatever the controller is trying to tell you, it's going to be in that alarm section. Then we have the configuration page. That's where you're going to be setting your pressures. If you want to enable automatic shutdown, that's where you're going to get into the advanced menus too for testing of the alarms. You don't test the alarms from the alarm page on here. This drop-down menu to alarms only sends you to active alarms. So in order to test alarms, you go through configuration, and it's in the advanced section. Then we have the history. The history is going to be your event logs, your power curves, your pressure curves, saved logs, and we'll get into that in just a minute. And then we have the service button. The manuals, which is also where you can download information. So if you want to get the logs and everything that we've been talking about, put in your USB, come down to this question mark section, and you can download the manuals and all the event logs and everything that the controller's been doing. And I think as-built drawings are in there as well. And then the language. I believe we do, what, Marty, like 20, I've heard you say 27 or something languages that we can.
I know 24 to 27, maybe we add some whenever we get it completed, but there's a lot. Depends on what part of the world you're in, but normally they'll be loaded anywhere from 4 to 6, 7 different languages. In the US, there'll be a specific language set compared to maybe Latin America or Europe or any place like that.
Right. But that's just the drop-down menu, and now we'll start looking at each one of these individually. So this is the alarm page. The drop-down menu to that alarm bell will send you here. Like I said, this is if you have any active alarms or if you've had any major alarms. We classify our alarms in 2 separate ways. There's the yellow ones that are, I guess you'd call them basically the FYI alarms. They're just, they're important alarms to look at, but they're not the critical ones. So they're put as yellows. Critical alarms are red. So this one right now is showing that we have 2 active alarms going. Both of them are cautionary ones. It's over voltage, and which the over voltage is part of the pump room alarm, which is why you're having 2 showing up on here. So pump room alarm, over voltage is just kind of, it's one of those group alarms in that section. If it was, I would imagine it's a yellow case for under voltage here because it's not to a critical point. It must be within some sort of tolerance, because if it gets too far out of tolerance, it would be a critical alarm. But you can also see here where it says loss of power, and next to loss of power it says it was occurred, but that's a critical alarm. So you can see it's red. Critical alarms do not clear themselves. The yellow alarms do. So if you have pump on demand, that's a yellow alarm, that kind of stuff. Over voltage, once it's corrected itself, it does go into the data. The database will always keep track of any of these kinds of alarms, but they do that automatically. With the loss of power, the critical alarms that are red, even after they've been sorted out, which this one says occurred, meaning it's not active, it is not a current problem, but it was a problem. We want that to be acknowledged, so it will show up in this alarm page until somebody comes in here and says reset. So you can see that down here on the bottom left. Once you reset, it'll clear all the occurred alarms. Active alarms, however, will not be cleared. As long as they're active, they're going to stay there no matter how many times you push the reset button, because there's something that needs to be taken care of. This is the gear, the configuration page, like I mentioned when I was showing the drop down. This is where you're going to set your cut in and your cut out pressure. You can see that here at the top. We have cut in and cut out. And just to explain this check mark here next to the cutout, from the factory, we have it set to where the check mark is not there. It's just a gray, or I guess it's a white box, and cutout is grayed out. What we're doing here is having you select the cut in and then automatically doing just 10 PSI above that for cutout. It's just a factory default. If you want to have your cutout set differently than that, you just push that check box, that clear box there, and it'll put that check mark in, which then allows you to modify the cutout. So you can set the cut in and cut out to whatever you want to based on the system requirements. But just a note on that we do have it set to where cut in is the only thing you have to enter, and it automatically populates a cutout 10 PSI above that. This is where you can also enable the periodic test. The periodic test is always active if, as long as that button on the front is functional. But that's where you would have to manually come in and do the periodic test. So you manually come in and push it, just like a manual start where you're just pushing the green button and it's a manual start. When you come in and manually press that test button, that's where it will open up the valve, drain a little bit of water, and do a test. And it'll run the test for whatever. If it's a diesel, it's 30 minutes. For the electric, it's 10. But you can also set it up to do a periodic test and do it automatically. So you can come in here and enable periodic test. You just click in that gray or that white box there, and you can have it come up, you know, as a weekly test, a bi-weekly, a monthly. You would change that down here where it says weekly test. You can drop down this menu and change to how frequently you want it to come on, as well as what day and what time and for how long you want it to run. So a lot of people don't use that periodic test. It's not, you know, one of the things with running your test is that somebody is supposed to be present at all times. If the pump is running, somebody needs to be in the room. And in that case, you could just push the button. So it's not necessary to set it up to come on automatically, but it is an option. The run test, that's going to be how long the test is actually being run for. That's actually controlling how long that front button operates. So if you press that, it'll run for 10 minutes. Then automatic shutdown. So automatic shutdown, this is where you would come again to enable that. It's the same process as all this other stuff. You just need to click that checkbox and it'll be set up for automatic shutdown. So very, very easy to field program these control panels with those types of adjustments. You can change the date and time here as well, depending on how long your control panel has been sitting. You know, sometimes the job sites, our panels get delivered and then they sit for several months. So your date's probably going to be wrong, but it's very easy to change your date and time. You don't need a password to do that. You do need to have a password. I should have started with that. I should have led with that. Down here at the bottom, you'll see user login. This one is already unlocked, which is why all of these boxes are white. They're able to be configured. When you first come to this page, that lock is going to be locked. And all of these boxes are grayed out, so you won't be able to actually make any adjustments. So we give passwords to people that we have authorized to work on our control panels. It's life safety, so we want to make sure that everybody that has a password has been trained and factory authorized to be working on control panels. So we have it password protected. But once you get your password, then you come to these, and these everything would be unlocked at that point in order to change pressures and enable automatic shutdown. There's also this advanced feature, which we're not going to be getting into all the advanced features right now, but advanced is going to be, like I mentioned, where you're going to be doing your alarm testing. And alarms are actually one of the very first things once you go into the advanced segment. Alarms are the very top of that list, and automatic. I'm sorry, the phase reversal test is going to be the first alarm. I know that's one that a lot of people, it's part of the startup process. So that's one people are always looking for. It's advanced alarms, and then it's the very top alarm on there for doing the phase reversal test. Moving on to the history. History is going to be where all of our events, our pressure curves, our power curves. You can see where it says saved logs. So the events, the top line there, the event line is going to be, it's going to show you the first or the most recent 500 events. And it's keeping a lot of data. So it's a lot, I mean, there's a lot of things going on there. If you push a button for manual start, it gives you, I think there's about 10 lines just for pushing that button. So it's keeping track of a lot of different things. As far as the functionality of the control panel. Once it gets past that 500 events, everything gets archived into this saved log section. And the neat thing about the saved logs is that you can actually go in and look by date, look by month, look by year. Anything it's keeping track of a lifetime of events of this control panel. And so if you know you had something that happened in, say, July, you can go back into the saved logs, sort just by that date, and kind of narrow down exactly what you're looking for. It helps find an issue in a system. It's a lot more efficiently than trying to scroll through just in a whole database of events. So that's what the date and timestamp is really good for.
One comment there is that you can do that right there in the field off that screen. You don't have to download it, put it to a desktop or laptop to review it later. You can actually look at all the history from day one in the saved logs by month, by day.
Yeah, that is a very good feature. And you can download it as well. So, I mean, all of that stuff, even the archive save logs is going to be part of that download that that you can get from the USB. Pump curves is something that, you know, we don't really use a whole lot, but we do have the capability of entering manually a pump curve. You can put up to 10, I believe you can store 10 of them in here, so you can kind of compare year after year of an annual flow test if you want to use that function. You just need to put in a couple set points, and it'll kind of build the curve for you. There is a way to do it automatically. That's where you would need to send us a signal from a flow meter, a 4 to 20 milliamp signal. We can get the flow. We'd already have the pressure, and we know the voltage and the amp. So it's pretty easy for us to build a curve. We just need that flow component, and that would come from a flow meter. The statistics is going to be your data from all of your starts, how many times the generator is run. We're even keeping track of the jockey start and stops here based on pressure. But there's also a place that you can enter in the jockey cut in and cut out for more accurate readings on that. But the statistics is going to be covering a lot of stuff. Your first powered on, your lowest ambient temperature, your highest temperature, is keeping track of a lot of data inside of statistics as well. And then the download function. So there's two different places that you can come and download. You can either do that drop-down menu to the question mark, or you can come through this way through the event logs, and there's a download section here, but both of them will take you to the same screen. This is the service page. Shipped from the factory, it'll say Tornatech, gives our phone number and everything right there. This little section. You actually can put your business card in here. I don't know what type of file it takes. It takes a certain kind of image file, but you put it onto a USB, connect it into the USB port, and then just tap on that spot, and it'll automatically upload your business card into the service page if you so desire. That is an option. But on this page, you'll be able to set a service interval as well. So if you want to have a message pop up that says service required, you can have that pop up. The intervals are, I believe it's 6 months, a year, maybe a year and a half, 2 years, and then 3 years, I think.
Yes.
Okay. So you can. It doesn't come factory set to do that at all. Somebody would need to come in here and enable that. So if you're a service company and you want to have a reminder set on this page that you know, for them to call you in a year for the annual flow test, it'll be, this is where you could do that. You just set the interval to 12 months, and in 12 months it'll pop up on the screen saying services required. Also, this is where I mentioned before, you can set the jockey pump cut in and cut out. So this helps us with statistics, with keeping track of starts and stops. It really does kind of tell a lot about a system if your jockey is constantly coming on or going off, or if you have an issue with the you know, the main panel is coming on and the jockey is not. You know, I mean, it's a good spot where you can keep track of what's going on inside the system. So this does not actually control the jockey panel in any way. It's not telling it when to come in and come out or to go off, but if you put the cut in and cut out in here, it just gives us more accurate data.
If you don't input the cut in, cut out of the jockey, you know, your accuracy range might be 85–90%. By putting it in, it's going to be much higher, 95 plus. I mean, probably closer to 98–99. I'm just ballparking. It does it by the algorithms. It's sensing pressure of decrease, increase. And at the same time, like Cole mentioned, in your event logs and your data, it's tracking statistics. It's tracking the number of operations the jockey is actually cycling on and off. So it's tracking that too.
Right. These are the languages. Like we mentioned, we do a lot of different languages, so that you can come in here and change language. One thing to note, if you change language and then there's a bunch of events, say you've just been, you know, you've switched it over to Spanish or French, and then you go through and you do some starts and stops, all of that's going to be put into the system as you know, in French or Spanish, and then you can switch back to English. But those events are going to stay in that that language. But anyway, we do have the capability of doing a lot of different languages. Some of the visual indications. These slides coming up are a little bit boring. We just, to show you list of the visual indications. We've already shown the screens of what they look like. But these are some of this is just written out what all we're having to show on the ViZiTouch. And the ViZiTouch just makes it a lot easier to see these things. But the power available, the motor run, periodic test, manual start. So that's one thing that we didn't have on the screen. Whenever you start the panel or start the pump, the panel is going to display how it was started. So if it was started manually, it'll say manual. If it was started on a pressure drop or whatever other automatic means, it'll say automatic. If it's a deluge, it'll say deluge. For emergency start, it says EMER. I think it might say emergency all the way out. But
EMERG.
EMERG. So whatever your starting method is, it'll say, it'll tell you on the screen. Plus, it'll log it that way as well. Remote automatic start, remote manual start, pump on demand, low discharge pressure, pump room temperature. That's not required, but we do that. Pump room temperature, that's up on the top right. And then lockout. So if you have a transfer switch, we also have to have visual indications for the position of the isolation switch, the voltages, which I showed you on that one as well, where it's right below the normal power is where you're going to see the emergency power voltages, and then whether or not the transfer switch is in normal position, which is where we indicate with that triangle. Well, that's the indicator if it's on normal power or on alternate power. And then also transition timers. Some of the visual alarms. There are several of them for that as well. Controller voltage not healthy, fail to start, invalid cut-in. All of these are going to be alarms that are going to pop up on the screen and go into the alarm section. Overcurrent, under voltage. All of the data that you see on the ViZiTouch is let's say it's the true RMS value. So when you're having the voltage readings where our demos and these pictures show a very healthy 480 volts, obviously the real voltage is going to fluctuate a bit, and you're going to see those numbers going up and down. Same thing with the motor amperages, it's going to fluctuate a little bit. And overcurrent, under voltage, those types of things, they're watching all of that data, and anytime that there's an issue, it's going to pop up with an alarm on the screen. And if it's a yellow alarm, like I mentioned, those are the they're important alarms, but they're not critical alarms, and they pop up as yellow. For instance, pump on demand. The pump is running, and you'll see a yellow bar on the bottom of the ViZiTouch that says pump on demand. So any of the alarms that's happening are going to be flashing on the screen. If it's a yellow alarm, it's a yellow bar. If it's one of the critical alarms, it's going to be red. So if you have something major, like you've lost a phase, or the phases are unbalanced or something like that, if it's a critical alarm, it's going to pop up as red, and it'll be scrolling through that red section saying what the alarm is. In order to isolate that, that's where you can go to the drop-down menu and tap on the alarm bell, and that will tell you, it'll show you everything that's happening on the panel. These are more of the visual alarms. Phase loss, like I mentioned, those are definitely critical alarms. Phase unbalanced, pressure transducer fault detected. There is a lot of different things that we're having to keep track of constantly. More visual alarms on the transfer switch. Automatic transfer switch trouble, phase reversal, locked rotor current. And some of the audible ones, like I mentioned before, if the transfer switch is open or it's tripped, it's not functioning, that's actually going to be ringing the bell. So that one is a critical one. The critical alarms are going to get a bell ring as well as a visual indication. All right, now we're going to move over to the diesel. That covers everything on the electrics.
So the diesel, the one thing that we'll do, we have other classes that we'll be having virtually. One will be a live view of the V2 demo itself. It'll be very thorough, and we have a lot more time, but PowerPoint slides are great to get the impact across, but a live view, a real live demo is going to have a lot more of an impact. But that'll be a future training session too. GPD diesel, let's get into this here. Again, diesels are just another way of turning a driver on for a pump when the pressure turns on. Basically, every system you have requires a cut-in pressure, and that's unique to that particular location or system. So electric's one thing, it starts a motor. With diesel, obviously we're starting an engine, but everything parallels. It is going to send a signal to start the engine with a pressure drop. The only difference is it's not a motor, it's an engine. We're not going to size it by horsepower and voltage. We just need to know what voltage the batteries are going to be and what voltage, AC voltage, you're going to use to maintain the chargers. 12, you can see right here, 12 and 120, 208, 240 is the incoming power, just single phase going into terminal blocks. That's what's going to feed the chargers themselves. The next key really is, do I have 12 or 24 volt batteries? 24 volt, you see those, that's going to be a huge engine, but predominantly what you see is 12 volt. 24, again, huge engine. So this one controller, how do you size it? You don't. You can have the smallest engine available in the world or the biggest engine available in the world. I just need to know, is it 12 or 24 volt batteries? Is it 120 or 240 or 208 volt for the incoming AC? And again, you don't see positive ground anymore. That's old. Probably still some out there, but it's negative ground system. The key here, you have two battery chargers independently automatic of each other. They're 10 amp continuous charge. So if your batteries are really, really low, it goes into a bulk charge. It will lay in 10 amps continuous charge into those batteries until they reach a certain level. The trickle charge, which is just a maintenance or minimum charge, it's a half amp, 500 milliamp trickle. Again, not to reiterate, but we have the same pressure block. We have a pressure transducer. We have a test manual test solenoid here. The 0 to 500 psi is working pressure, standard 0 to 3, externally mounted wetted parts. It's the same as the electric. So I will work through this because it's redundant. We still have the same retro bell, about 85, 90 dB. I mean, obviously, when I was growing up, we heard bell, it was fire alarm, or it was lunchtime. So it's that kind of a bell. Enclosure, NEMA 2, drip proof. You can see the alarm here. Externally mounted wetted parts, which is our pressure connection in here for our half-inch sensing line. It's a NEMA 2. As I mentioned, it's lockable. Latch and a lock up here. Here's your operator. Handoff auto selector switch. Obviously, that's a requirement. And what do we have? We have it in hand to manually crank. We have it in off, or we have an auto, which is crucial, automatic. It's very compact size. Typically, you'll see these wall-mounted or skid-mounted, but you can order a pedestal, which is 19 inches. It's optional. I mentioned the handoff auto selector switch behind a breakable cover. Comes with a lock. You lock it into auto. If you ever need to break it off, you just twist this. It'll break off the ridge here, and you could put it into off. That's primarily what it is. You'll see people that still have the old little metal door with a glass cover that you got to break. But this is per UL, FM, and FPA 20 requirements. It meter exceeds. Keep it simple. All right, here we are. Crank 1, crank 2. Again, operational features. We start on a pressure drop. We can do a remote start signal from an automatic device. Typically, what will happen is if you do have an automatic start, it will literally sit there and crank 3 consecutive attempts on each side. So it'll crank for 15 seconds on number 1. It'll rest for 15 seconds. It'll then crank on number 2 for 15. If it doesn't start, it'll rest again and go to crank number 1. And ultimately what happens is, by code, you're going to do this 3 times on each side. And if after 3 cranks on each, crank 1 and crank 2, after 15-second rest in between, fails to start the engine, you will have a engine fail to start. That's a rare situation, but that's part of what we do when we do the testing on commissioning. Of course, you do have manual start. You would take your handoff auto selector switch, stick it in manual, and either hit crank 1 or crank 2. Stopping, obviously, manual stop button. Or you can go to the engine. There's a toggle switch on the engine itself that will allow you to stop the engine too. You do have similar timers as you do in the electric. It's pressure or non-pressure, automatic or non-automatic. You may have a pressure actuated controller, electric or diesel, but the point is you can switch it in the field to a non-pressure. Maybe you made a mistake and it's a foam application or something like this, but you have that flexibility in the field. Again, we talk about the run test push button. As I mentioned, similar to the electric itself, what we have is meeting NFPA 25 requirements as you do weekly tests of the engine itself for 30 minutes. Runs a cycle. You can press this button. It drains minimal water out of that test solenoid right here. And basically what's going to happen is it'll just use a little bit of water. It'll exercise the pressure transducer, drop in pressure. It'll run for 30 minutes and then shuts off, but it records it as a test. Here's something I'll do really quick here. When you get into an automatic start, a manual start, or remote start, it thinks there's a potential fire. The reasoning is someone started it manually, someone remotely started, or it's an automatic. If you have high engine coolant, low oil pressure, high pump room alarm or low pump room alarm or low fuel alarm, it's only going to alarm. It will not shut it down. Why? Because it thinks there's a potential fire there. It doesn't care what happens. But if you do the run test, because it knows it's a test, any of those items will cause, well, typically the main ones, high coolant, low oil pressure, will cause it to shut down. When you get into low or high ambient pump temperature, it's alarm only, or low fuel level, it's alarm only. The one item that will shut down regardless if it's a fire or not is overspeed. Overspeed is that option, just like in the electric where you have locked rotor current, 600%, 8 to 20 seconds. There's more potential damage there by not tripping it offline. The same thing when you have a runaway engine, what happens? You're going to have overspeed. Obviously, you could potentially exceed the parameters of the mechanical parameters of the motor and cause it to blow something. But you're going to overpressurize the system and your piping's probably not going to hold. Let's just look at remote standard. Again, standard remote alarm. Same thing. It's 8 amp, 250 volt, controller trouble, engine, run, louver activation circuit. 8 amps is a lot. And your louver activation circuits typically aren't going to exceed 8 amps. And we want to know, is it hand or off? Because if it's in hand or off, you do not have fire protection. It's not an automatic. And then you have incremental extra remote alarms right here. We kind of covered those in the electric also. Pull apart terminals. Again, external, let's look at this. We're looking at typically, again, bell, externally mounted wetted parts, handoff auto selector switch, the operator, lockable door, externally accessible USB port that you can download all your data. Internal components, let's make it quick here, quite easy. We run our 120 or 240 into the terminal block, actually the terminal block here, which runs into an EMI filter. We run it through an AC breaker, and then it feeds both of these chargers themselves. And again, that diesel controller has two jobs. Number one is when the pressure drops below cut in, it turns the engine on because it thinks there's a fire. Number two is there's chargers. We need to maintain the battery charge itself. And 13.8, you know, is awesome. Anything below 12.8 or something, your batteries are at risk, and your amperage is below 1 amp. There's an issue there too. Now, from the chargers, we go through a DC breaker, 2 DC breakers out to both of the battery banks themselves. 1 through 12 is right here. That's industry standard. Doesn't matter what manufacturer engine you're using, 1 through 12 is standard. You know, 1 is the fuel solenoid, 2, 3, 4. These are all alarms. Normally it's a number 14 AWG. It's alarm wiring. 6, 8, and 11 are power. 6 and 8 are battery. 11 is ground. Those are power. And so there'll be labels in the controller that will tell you, I want a heavier gauge or dual solid cabling running to 6, 8, and 11, because that is, again, ground and battery connections. It's not just an alarm. It's carrying a lot more current. You still have your bottometric land plate. Makes it quite easy. Straight in wiring here. Pull apart terminals. Field connections. So, again, I'm just going to cover a few of these here, but fuel level, remote auto start, deluge start, fuel tank leak, high fuel level. Those are all standard. Engine terminals we talk about here. Again, what I'll point out is 1 through 11 used to be what it was probably 10 years ago, but we go 1 through 12. And 12 is, for a lot of the engines now, you energize to stop.
Marty, just one note on those. The number 7 wire, obviously, y'all can see there is no number 7 on there.
Yes.
That is the alternator output current divider. If that's required, we do need to know that.
Yes, thank you.
Ahead of time. So if you have the number 7 wire, if it's a diesel replacement panel and you have the 7, we need to know that ahead of time.
You know, it's an option on the front end, and I'm telling you, it takes a bit of time to install it in the field after the fact. Right. That's a very good point. Thank you so much, Cole.
Yep.
Engine connections. The 300 series were added through the years. I think really the last couple, high raw water temp, low raw water flow, and LET, low engine temp, were the last ones that were added. Obviously, they're crucial alarms for the engine itself. Again, the ViZiTouch, I'm not going to cover this. We just did this. Same here. Everything's identical. But I will show you this picture. So here's our chargers. Here's our amperage, 1.1. Here's our battery voltage, 13.8. Those are very healthy batteries. And you can see green. Green is good. The starters, they're open. The engine is off, and the fuel solenoid is up in the red position or off. Everything else is the same. You see what condition is automatic, pressure actuated, manual shutdown. You see cut in, cut out, system pressure. Everything here is the same. Alarms and events, the same thing. There's just more of them. Configuration, identical as the electric. Events, pressure, power, save logs, pump curve, statistics. As I mentioned, event logs and statistics are a text file. Basically, it's chronologically listed. If you had pressure curves, power curves, if you did pump curves, that would end up being in a spreadsheet, but it wouldn't be curves. It would be values. We covered the service page. Just send us your business card if you want it, and we'll have Melissa create something on a USB to send out to the field. So pretty much everything is the same here. Language, same way. Visual indications. Lots of them for a diesel. Lots of alarms. The bell will ring a lot more. Obviously, you see engine run is an auto position. Cranking cycle. AC power. More visual alarms. The key ones here, obviously, do I have charger failure? Do I have over voltage? Weak batteries are another one. It really gives you every little aspect of the system itself on a diesel. Visual indications again here. Low suction, water reservoir low, low pump temp, we talked about that. Service required, ECM warning, that's from the 300 series. Now these are visual and audible. Not only will you see it on the screen, but the bell rings. More visual and audible. And I hate reading them, so I'm letting you view them yourself, because I'm sure a lot of you have the experience in dealing with diesels also. That wraps up our presentation, and we invite you and look forward to you attending future ones that we'll have throughout this year. On behalf of myself, I thank you for attending. And Cole?
Yep. Thank you, guys. Thank you very much for attending this.
Hi, everyone. We're back live here to answer your questions. We hope you really enjoyed that presentation. We tried to go into a lot more detail than we did previously in our virtual summit. And as Marty had mentioned, we will have a lot of more detailed webinars going on in the future that go way more into depth than we did in our virtual summit. So let's get started with our questions. While we wait for some to come in, Marty, are there any points that you would like to add to the presentation or review some questions that you have received in the chat during the presentation?
A couple things I think I mentioned during the presentation, and I apologize because we proceeded to do a PowerPoint presentation kind of reviewing the V2, the ViZiTouch, which is really the technology behind a fire pump controller. And what we're actually going to do is do a live view presentation in the future, which is going to be purely the ViZiTouch on electric and diesel with a live system. And there'll probably be a lot more interaction on some of the questions coming in when you do something like that. But, you know, my apologies there. As far as questions, you know, there's a couple that was that came up. I will tell you on operating handles, you know, there is, we have designed our own operating handles for the normal power and emergency power flange mounted operating handles itself. And, you know, we've had it for quite a bit of time. And I'll make a comment about this and then go offline with emails for specific people. But usually authorized service people are the ones that would be allowed to have access to have the power handles turned on. And there is a way of defeating the mechanism that's internal to open the door when the power handle's turned on. And I say authorized people because when you open a door with the power turned on an electric controller, obviously you have potential arc flash there with the incoming cables from the utility. So we always stress safety, making sure you have your PPE equipment on, or you might have a main fusible disconnect or one of our OPDs, which is a main disconnect circuit breaker design ahead of the fire pump controller in the off position, which allows you to actually open the door regardless. So any questions like that, I think there was one or two about defeating that mechanism. I take it offline, deal with you one-on-one because we want to make sure that you know, safety is number one. As far as some of the other questions, typical, we've had a situation with our battery and maintaining batteries. We have it set up because it's life safety, so that even though we have a lithium-ion battery, it's a very high-end battery, it has a certain amount of charge when it leaves the factory. And depending on how long it sits in the field, this battery is not turned off for any condition because we don't want to have power turned off in a situation where, again, in the field, you want to have that circuitry energized 100% all the time. But what we're running across from time to time from a few people that have actually brought questions up is that if the battery isn't charged within about 25%, there might be a potential situation that occurs to the screen of the ViZiTouch. Well, this has been rectified. And it's not the battery. We actually came up with a resolution that was done by updating our software. We had R&D check into this, and I'm sharing this with you. But again, it's for really the benefit of the controller itself, for the longevity of the battery. It was not really a battery situation. But what you've run into is a situation because based of longer startup times. I think obviously from the pandemic, you have equipment that's sitting there longer, and it's a natural thing for any battery to discharge over a period of time. Some more than others. That's just natural. So, the suggestion on response there is to turn the power on, let the battery kind of charge up. A lot of times it doesn't take a long time to do that if you're realigning the pump or whatever. It's just part of the startup procedure. But we have gotten a solution via software, and there will be a technical memo sent out to everyone in the field shortly. We're finishing up that right now. That was a couple of people.
I have another question that actually just came in from Brett. Thank you for your feedback. And he asked, is this being recorded so that we can view them later? Yes, all our webinars are recorded and available on demand within usually about a week. It just depends how long it takes us to process the video. And I actually have another question from Jacob. Is it possible to have the power come in to the bottom of the panel on either side? Example, if the connection is usually on the bottom left, can it be configured to come in bottom right?
Well, I guess we're talking with or without. You could have transfer switch. Let me clarify. If you have a transfer switch, a lot of times you can have an option to switch the transfer switch from the right side to the left side. So you've got main incoming power coming into that side. If it's just a regular electric controller, what you have is we do have a gland plate there, and a couple of zip screws. You just remove that, but as long as you come in the bottom 12 inches, you can come in the side, you can come in the back, or you can shift over. You're still going to have to loop your cables up and around into that ISO switch on the top right side anyway. So you have to take it. And again, if you have any questions, you can reach out to us on a case-by-case basis. But we have updated our literature, our manual. We're doing it right now that actually clarifies, yes, you can come in the first 12 inches from the finished floor of the enclosure on the side or in the back. But again, if you want to come in on the left side instead of the right, where that gland plate is, kind of like off center right, it should not be an issue as long as the cables are run up properly to the ISO breaker itself. Hopefully that answers the question. I see it.
Yeah, he said thank you. I have another question here sent in. Does Tornatech offer a standard parts kit for service providers, e.g., spare boards, relays, transducers, etc., to bring to sites?
To answer your question, through the years, we have done isolated situations where we put together a package of a spare parts kit or a startup kit. And this is actually on the table right now. We're discussing this and trying to determine a plan that we could roll this out. I don't think it would be carte blanche to everyone across the US. It would be more specific as to the needs. So if you do, please email myself, email Cole, and so we have you on the list. We can discuss that one-on-one. But yes, we have in the past, but we are actually looking at a program right now. I call it Startup Kit, having spare parts individually in individual locations or representatives who are doing commissioning or authorized service providers that we have. So we are looking at a plan like that right now to take it a little bit broader scale than what we've had through the years.
Okay. So we have another question. I miss how to calibrate jockey pump with a fire pump controller, or do you recommend inputting the jockey pump on-off PSI into the FPC?
Calibrating the jockey pump is pretty easy. So this is a tough one. You're going to me, you're going to have gauges on the main fire pump controller anyway. So you want to really make sure that the main fire pump controller itself is aligned with those gauges. But at the same time, that jockey should be, in my opinion, aligned with similar to the gauges too. It might be off. You really shouldn't have much differential between the jockey and the main fire pump controller. Sometimes there is. I would adjust the jockey.
Great. There's another question here. Is there an option for an alarm or indication that the door is open or door is open with power on?
The answer to that is I'm not aware. No, there really isn't an interlock with the door. So the way it's set up now, you cannot open that door with the handle in the on position. There's only one particular way you can, but it's for authorized people, authorized service providers from us. Anyone who actually is able to defeat the internal mechanism, and there is a way from the outside, and that's pretty standard for controllers and across the industry, whether it's fire or non-fire. You have a defeating mechanism on that operating handle itself. Yeah, there is a way of doing that. There is no alarm when the door goes open. Why? Because the only people that are going to be able to know how to do that should be authorized. They should know the safety aspects and potential hazards. As I mentioned, one of the key things that's been in the code, even on the non-fire side in NEC, is arc flash potential. And that's an educational thing, not only applying to people that are working on our controllers for powering up the electricians and so forth, or authorized service providers of ours, but even alarm people coming in and terminating their alarm prior to commissioning. They're not always fully aware or educated that that door is open and you've got, the switch in the on position, that you have arc flash potential, and they're sitting in there actually just terminating their smaller multi-strand AWG14 for alarms. So the way it's set up now, pretty much for any manufacturer that I'm aware of, at least for us too, is that door is open, and if it's in the on position, there is no official alarm. Last comment on that is, usually a lot of times, depending on the install, you'll have the electrician who will put a label on that door who actually suggests calling them first before that door is opened. So even in the on position, we know there's an issue. You can defeat it and still access it, but those people are going to be qualified and understand the potential risk there. But even if you turn it off and you open that door, in most cases, the 3 power cables coming from the utility, the pole mount transformer, the pad mount transformer, or the one in the vault, in most cases, there's not a main disconnect ahead of that fire pump controller. So those 3 cables coming into the ISO breaker itself, they're still hot. They're live. Even though you have the power to the controller in the off position, you still have arc flash potential hazard there. And a good electrician, depending again on the install, will have a label that says arc flash potential. Please do not open without contacting us first. Most cases, they're more heavy industrialized or OSHA driven or institutional, like universities and places like that.
I have another question here, and I can tackle this one. Kayla asked if there will be future webinar on flow meters. And yes, there most likely will be a presentation coming up in the upcoming months about our flow meters. However, if you cannot wait, we actually have all the webinars available on demand that were part of our virtual summit. All you have to do is visit our website and go to the virtual summit page, or just directly follow a link on social media that we've posted, and you'll be able to see the on-demand presentation that we did. And we do have that presentation available from different presenters. So there's one that tackles the presentation based on your location. That's something that Tornatech is doing as well. We will have similar presentations available in different languages. Like, for example, this presentation will be available next week in Spanish, if that's what you would prefer. And again, we have this presentation, a similar one going on in December 15th at 7 a.m. Eastern for our Middle East and UK European market. So, I mean, depending your location, we have a sales team member creating that presentation based on market, market-specific questions that may be interesting to you as well. So now let's go ahead, Marty.
One comment
yes,
about the, as far as the calibration of the jockey pump or the controller, we have PDFs. In fact, I think we might have a video that's accessible 24/7 on how to calibrate the jockey pump controller. But we have a simple PDF that we can text you or email to you also that you can just hold on your phone or your laptop or whatever when you're in the field if you ever need to use it. It's pretty simple to do. The controller the same way. So just in case that was part of your question too.
Yes, and I believe we do have some calibration videos on our YouTube page as well for the fire pump controllers and the jockey. So I have another question here. On the diesel controller, is the fuel injector malfunction still on one of those alarms that is really a general alarm from the engine, or has that issue industry-wide been resolved?
That's a good question, and I'm just digging in here because I'm pretty sure what you end up. Let me just look real quick here, because typically I think it was the 300 series. You're talking a fuel injection malfunction, and on the diesel, I know there's a fairly extensive terminal set up on the 300 series, which covers a lot, like we talked about LET and raw water temp and so forth. Let me just look real quick. I'm pretty sure it is covered. I'll just go right to the pinout itself. Yeah, fuel injection malfunction is actually alarm 302. It's standard. So okay. Of that grouping, you have ECM selector switch and alternate position. Number 2, 302 is fuel injection malfunction. You get into a lot of different things, like I mentioned, the high raw water temp or electronic control module warning. So those are fairly interconnected, and they are standard. Yeah.
Okay, well, that's all the questions we have for today. Thank you, Marty, and thank you, Cole, from afar. I didn't know that you lost power and you were unable to present today to join us for our Q&A. Thank you, everyone, so much for attending our webinar. And again, please note, it will be available on demand. As long as you're registered, you will receive an email when it is available. But again, we would really appreciate your feedback on how we did today. Please fill out the survey that will pop up at the end of this webinar. So as Marty and I both mentioned, we will have more webinars coming up in the upcoming months. So stay tuned, check out the news on social media, follow us for the latest updates. And of course, we will be sending newsletters out as well.
As I mentioned, the live view on the V2 operator, which is really, we'll get in depth on that. We'll go through everything in great detail, screen by screen. Rather than using a PowerPoint, it'll be interactive and live, and that really brings a lot of value, I think, because you actually see it, the reaction of changes we can make on immediate request by you. I thank you also. Again, I know Cole is in a unique situation, having lost power, but I know many of you, I see the list. I greatly appreciate the time that you spent and participating and listening to our presentation, and look forward to doing more. Thank you very much.
Thank you, everyone. Take care.
Bye now.
Bye. Have a great day.